This video is part 3 of a 5-part series of videos about basic trigonometry. Part 1 talked about labelling a right angle triangle so that you can do trigonometry on it, and part 2 talked about the 3 different trigonometry rules: sine and cosine and tangent. And did I say part 3? I meant part 2. This one's part 3, and we're going to be finding a missing side using trigonometry. I call these type 1 questions. There are 3 types altogether. So, oh dear. There are, as you know, 3 trig ratios, and there are 3 types of questions that use those trig ratios. And in order for you to recognize the type without having to worry about which trig ratio is being used in which situation, I'm going to demonstrate all 3 types in the next 3 videos using only the tan ratio. So one step out of all of your calculations you won't have to think about, because that one step will be, what ratio are you going to use? We're going to use the tan ratio, just so that you can get to recognize the 3 types. So this is called type 1. Type 1 is find the missing side. This is the most common use for trigonometry. In fact, type 2 finds the missing side as well, but there are differences. So our first step in solving any trig problem is to label the triangle, and we spent a whole video watching that, learning how to do that. So I've got the little sides over here, remembering that if you make an arrow out of the right angle, it'll point to the hypotenuse, and that's the one you do first. Then if you're sitting with your bottom on this corner of the triangular room and you throw a tennis ball across the room, it's going to hit the opposite side, and the other side that you can beat with your fist when you're sitting in this corner of the triangular room is the adjacent side. Adjacent means next to. So tick, we've labelled the triangle. The next thing we're going to do is we're going to put a circle around the sides that have information on them. So here we've got some information on this side. It has an X on it. And here we've got some information down here. Now you might say, I've got something written on this side as well, but I didn't have anything written on there until I put the H on there. So the 2 sides that we're comparing in this particular problem are the opposite side and the adjacent side. And you'll remember from your rules, opposite and adjacent is tan. So we're going to write the rule. Now remember, it'll always be tan for this video and for the next video and the one after, until we get used to the 3 types. So we're going to write the rule. And then thirdly, we're going to substitute into the rule. Here's one I prepared earlier. Let me see if I can scroll down a bit. There we go. Let's pick him up and bring him up. So, first thing we do is we write down the rule. We've identified it, we've circled the opposite and the adjacent, we realize that that must be tan. Then we've put the information into the rule. Now the angle there, you can tell it's an angle because 1, it's inside the triangle, and 2, it's got a degree sign on it. That goes with the theta. Remember, theta always represents the angle. Then, being very careful, we identify the symbol or the number that's on the opposite side, and we put it there on the top, and the symbol or number that's on the adjacent side, and we put it on the bottom. Now, here we have tan 41. Tan 41 is just a number. You press tan 41 on your calculator, it'll spit out a number. It'll be an ugly number, but it's still a number. And x over 13, x is what we need to know. So we need to get rid of this over 13. Now you'll remember from your days with algebra that over 13 means divide 13. And if we want to get rid of it, we need to do the opposite. So we need to multiply 13. We need to multiply it on the other side. So here I have it multiplied on the other side, 13 times tan 41. Now I could write tan 41 times 13, but I would not like you to accidentally find the tan of 41 times 13. 41 and 13 will never be multiplied. 41 is an angle, 13 is a side. This is degrees, this is centimeters, they don't mix. They're not friends, their families are not friends. So, in your calculator, 13 times tan 41, in that order if you've got a modern calculator, gives you 11.3 centimeters. Check to see whether or not the answer makes sense. If it was 113 centimetres, I'm thinking it's unlikely we're going to have a triangle that has a side of 13 and another side of 113, so that would be a mistake. Also, we need it to be, we don't know about the hypotenuse. Scratch that, rewind. So, go back over this and make sure you understand all the steps, because on the next screen, I have 4 questions for you to have a go at. So you will need to pause the video and then write these questions, draw the diagrams on a piece of paper on your book and have a go at each of the questions following the steps. Pause the video. No, pause the video. Excellent. So, how did you go? Now, I'm going to have a go at doing these questions, and I'm apologising in advance for the dreadful handwriting I'm going to show you, because I'm using a new tool and it's a sort of thingy and it makes me write really messily. Now, my writing is normally very messy, but you ain't seen nothing until you see the messy writing I'm about to show you. So, let's look at this first question. I've cleared some space around it because not only is my writing going to be messy, it's also going to be big. So, we're going to, first of all, step 1, label the triangle. So let's label the triangle. And here we go. So we're making a little right angle out of, that doesn't help, helps if we've got a pen. A little right angle out of the, a little arrow out of the right angle, and then we're going to label that an H. And then this is the opposite side, and this one here is the adjacent side. Then we're going to put a circle around the information, sides that have information on them, and we're just going to go through the motions of saying opposite and adjacent. Oh, I wonder which ratio that is. Oh, it's sokotoa, toa, toa, it's tan. Surprise, surprise, tan. So we're going to write down our rule, which is our second step. So tan theta. Do put the theta. Some people just put tan equals opposite over adjacent, and that's just bad. Because on the second line, when it says substitute, on our next step, what are you going to substitute if you don't put a theta in there to keep as a placekeeper for the angle? So then we're going to substitute in. So the angle, down here, we know it's an angle. It's got a degrees on it. It's going to go here instead of the theta. And the equals really should be under the equals, but I'm just having difficulty making my writing legible at all. Here we go. X is being very, very careful. X is the side that has the opposite marked on it, and A is the 12.8 meters. I'm leaving the meters out for the time being. And, surprise, surprise, the 12.8 is on the bottom of a fraction. We need to get rid of that divide by 12.8 by multiplying it. And remember what I said about multiplying on the front. Ooh. Oh, I'm going to run out of space before that equals. Ooh. Equals X. So we then get our calculator out. Can't find the calculator, there it is. And I've done this already before. Let's clear this. Now my calculator is an old-fashioned, it's almost as old as I am. And unfortunately, unlike your calculator where you'll be able to just put 12.8 times tan 46, my calculator insists that I go backwards. Mine goes 46 tan times 12.8. And press equals, and we get, that is wrong. I'm going to have to do that again. Give me a second. I know it's wrong. 169. Let's have a little think about that. Imagine if that side was 169. There's no way, Jose, that that's right. Let's go again. Probably because I paused the video. So that times 12.8 is, there we go, 13.25. Now, I'm going to do 2 decimal places because there's 1 decimal place in my question. I always like to do 1 more than is in my question. And let me just find my pen again. There we go. So X is going to be 13.25. Now, I've already done the, gee whiz, I wonder if that's okay. dear, that I must have right-clicked that. And don't forget the meters, because there's meters in the unit here, so therefore there's going to be meters in the answer. Now, 13.5 is a much more sensible result. I'm hoping that you agree. 46 degrees is really close to 45 degrees, and a 45-degree right-angle triangle has two equal sides, so 12.8 and 12.8. So 46 is going to be slightly more than 12.8, and 13.25 in my very messy writing there is about that. So I'm going to do one more, but I'm going to have to clean up the screen first because I don't have enough room. So let me just get my good old eraser out, and we'll move this one across. Actually, let's do this one instead because it's a little bit interesting looking, and it'll really determine whether or not you know what you're doing with the labelling. Okay, so first step of any trig problem, label the triangle. Let's go with a different colour this time. Okay, so there's my right angle, and there's a very poor arrow there, so that must be my hypotenuse. And there's the tennis ball going across the room to the opposite side, and there's my adjacent side. Let's put a circle around this one and around this one, and oh, surprise, surprise, it's tan. So we write down the rule. Tan theta, don't forget the theta, is equal to opposite over adjacent. Oops. Tan, oh dear, tan, now what's the angle? It's this one over here, 67 degrees, is equal to the opposite side, which has x, and the adjacent side, which is 4.7. And I'm going to get rid of that divide by 4.7 by multiplying it on the front of the other side. So 4.7 times tan 67. Gosh. And that's going to be equal to x because I've gotten rid of the divide by 4.7. So let's get the calculator out. Remember, my calculator's old-fashioned. I've got to go backwards. The screen. 67 tan times 4.7. Now let's have a little think about what the answer might be. 67 is bigger than 45, so the side opposite is going to be bigger than the side next to it. So I think I'm going to be aiming for 6 or 7. Let's have a look. Oh, that was a very bad estimation. So 11.07, let's check the third digit. 11.07 I think will do us. So let me get my pen. Okay, so 11.07 centimetres. Okay, I'm going to pause this video, work out those other two answers for you, and just put them there so that you can check your answer. Okay, so here we are. If you did this question here, my answer was x is 24.79 millimeters, don't forget the units, and that looks pretty good to me. It's a little angle, so it should be opposite a little side. And this one down here, my answer was 44.77 millimeters. What's that you say? You got 44.76? You didn't round correctly. And that looks pretty good as well. That's a fairly small angle, so it's going to be over a relatively small side. Anyway, watch my next video to find out how to do finding the missing side type 2. Hope you learned something.